A common way of standardizing the form of a radical expression is to have the denominator contain no radicals. The process of removing radicals from a denominator so that the denominator contains only rational numbers is called rationalizing the denominator. This is done by multiplying by a form of 1. Let's look at some examples to better understand how this works. In part A, we have 3 over the square root of 7. Notice that there is a radical in the denominator. We need to remove this radical from the bottom. To do so, we take the square root of 7 and multiply it to both the numerator and denominator. The reason we multiply to both is because the square root of 7 over itself is equal to 1. This means that we are essentially multiplying by 1, which won't change the value of the original problem. When we multiply in the numerator, note that you cannot multiply the 3 times the 7 because the 7 is inside the radical bar. Therefore, we simply keep the numerator as 3 times the square root of 7. In the denominator, since both 7's are inside the radical bar, we can multiply them to get the square root of 49, which simplifies to give you 7. This gives us as the final answer 3 times the square root of 7 over 7. In part B, notice we have a fraction inside the radical bar. Recall that fractions are not allowed inside a radical. We can use the quotient rule for radicals to help us rewrite the problem as the square root of 18 over the square root of 125. Don't forget to keep the minus sign in front of the radical. We continue to simplify by rewriting the inside of each radical. The square root of 18 can be rewritten as the square root of 9 times 2, and the denominator as the square root of 25 times 5. Notice that we can take the square root of 9 to give us 3, but the 2 remains inside the radical. We can also take the square root of 25 to give us 5, but the other 5 stays inside the radical. This will give us 3 times the square root of 2 over 5 times the square root of 5. Notice that we still have a radical in the denominator. Now is when we begin to rationalize the denominator by multiplying both the numerator and the denominator by the square root of 5. This will give us 3 times the square root of 10 over 5 times the square root of 25. Note we can take the square root of 25, which is 5, which we then multiply to the other 5 in front, giving us 25. Our final answer is negative 3 times the square root of 10 over 25. In part C, notice we are working with the cube root and we again have a fraction inside the radical. We are given the cube root of 27 over 16. Again, using the quotient rule, we rewrite the radical as the cube root of 27 over the cube root of 16. Notice we can rewrite the 27 as 3 raised to the third power, because 3 times 3 times 3 is 27. We can rewrite the 16 as 8 times 2, but note we can further rewrite the 8 as 2 raised to the third power, because 2 times 2 times 2 is 8. Next, we can simplify the numerator by canceling out the power of 3 and the index 3. This will cause the base 3 to come out of the radical, so this radical is now gone. In the denominator, we can cancel out the index 3 and the power 3, again causing the 2 to come out of the radical. Keep in mind that the other 2 does not simplify, so that it will stay in the radical. Again, notice we still have a radical in the bottom, so we now begin with the process of rationalizing the denominator. We multiply both numerator and denominator by the cube root of 2. Note that because we are working with the cube root, we need to see this radical 3 times in the denominator in order to remove it from the bottom. So it is necessary to multiply the top and bottom by the cube root of 2 twice. This will give us 3 cube root of 4 over 2 cube root of 2 raised to the third power. Now we see that we can cancel out the index 3 and power 3, which will bring out the 2 out of the radical. Remember to multiply this 2 to the other one that was outside. This gives us the final answer, 3 cube root of 4 over 4. Whenever a radical expression has a sum or difference with square root radicals in the denominator, we rationalize the denominator by multiplying both the numerator and denominator by the conjugate of the denominator. In general, given a binomial x plus y, the conjugate is x minus y. Basically, you change the sign in the middle to obtain the conjugate. Let's look at a few examples to see how this works. In part A, we are given 3 over the binomial 1 plus the square root of 2. Notice we have a binomial in the denominator which contains a radical. so we need to rationalize this denominator. We begin by multiplying both the numerator and denominator by the conjugate, which is 1 minus the square root of 2. You can use the distributive property to multiply in both the numerator and denominator. This will give us 3 minus 3 square root of 2 over 1 minus the square root of 2 plus the square root of 2 minus the square root of 2 times the square root of 2. In the numerator, we cannot subtract the two terms because one term has a radical and the other does not. So they are not like terms, which means they will stay as is. In the denominator, the two square roots of 2's in the middle are opposites, so we can cancel them out. Also, we can multiply the square root of 2 times the square root of 2 because both 2's are inside the radical. This will give us the fraction 3 minus 3 square root of 2 over 1 minus the square root of 4. We can further rewrite the denominator by simplifying the square root of 4, which will give us 2. This means we will have 1 minus 2 in the denominator, which equals to negative 1. So our answer becomes 3 minus 3 square root of 2 over negative 1. We can simplify this answer further by dividing the negative 1 into both terms in the numerator. This will give us as the final answer negative 3 plus 3 square root of 2. In part B, we have 5 over the binomial 4 minus the square root of 3. Again, we have a binomial in the denominator which contains a radical. We begin by multiplying both the numerator and denominator by the conjugate, which is 4 plus the square root of 3. Again, we use the distributive property to multiply in both the numerator and denominator. This will give us 20 plus 5 square root of 3 over 16 plus 4 square root of 3 minus 4 square root of 3 minus the square root of 3 times the square root of 3. In the numerator, we cannot add the two terms because one term has a radical and the other does not, so they will stay as is. In the denominator, the two 4 square roots of 3 in the middle are opposites, so we will cancel them out. Also, we can multiply the square root of 3 times the square root of 3 because both 3's are inside the radical. This will give us the fraction 20 plus 5 square root of 3 over 16 minus the square root of 9. We can further rewrite the denominator by simplifying the square root of 9, which will give us 3. This means we will have 16 minus 3 in the denominator, which equals to 13. So our answer becomes 20 plus 5 square root of 3 over 13. In part C, we have the binomial square root of 2 minus the square root of 3 over the binomial square root of 5 plus the square root of 3. This time we have binomials containing radicals in both the numerator and denominator. However, we are only concerned with binomials in the denominator which contain radicals. We begin by multiplying both the numerator and denominator by the conjugate, the square root of 5 minus the square root of 3. Again, we use the distributive property to multiply in both the numerator and denominator. This will give us the square root of 10 minus the square root of 6 minus the square root of 15 plus the square root of 9 over the square root of 25 minus the square root of 15 plus the square root of 15 minus the square root of 9. In the numerator, we cannot add any of the terms because each term has a different radical, so it will stay as is. In the denominator, the two square roots of 15's in the middle are opposites, so we can cancel them out. Also, we can take the square root of 9 in both the numerator and denominator to give us 3 in both locations, as well as take the square root of 25 to give us 5 in the denominator. This will give us the fraction the square root of 10 minus the square root of 6 minus the square root of 15 plus 3 over 5 minus 3. We can further rewrite the denominator by subtracting 3 from 5, which gives us 2. This means our final answer is the square root of 10 minus the square root of 6 minus the square root of 15 plus 3 over 2. You should look over the examples on the web page and then test your knowledge using Test Yourself.